Now, it starts off pretty nice and gently. Part 1 of Part A. Essentially, all you needed to do was to do similarity. Now, don't forget, particularly those who are, used to living in Extension 2 land, and when things are similar, you can just say, by inspection, This is more important here. You can't skip over these kinds of things. Okay? So you've got OUT, that triangle, being similar to OWV. Okay? So once you've shown they're equiangular, you can come up with this ratio. Okay? So, of course, the reason for that is corresponding sides in similar triangles are in proportion. That is far and away the quickest way to say it. Now, when you rearrange that, that gives you your expression for capital R, this thing. Okay? So your expression for capital R, just a bit of rearrangement there. Whoops. Okay. So really that was the first mark for being able to produce that. And your second mark was for using just the area of a circle, namely the area of the shadow. Okay? So you had to get to the area being pi times this squared, and you were basically there. Okay? So R x plus d on x, or squared, and then of course you simplify a little bit, and you get to the, show that, done. Okay? So there was the second mark. Now in part one, there's a fair bit of work to it, right? But it's a very standard related rates question, okay? The question itself, even though it doesn't say it in the right language, it gives you the rate that you need to work at this rate. Where does it give it to you? It's right there at the end, isn't it? The light source is moving horizontally toward the coin at a speed of 4 centimeters per second, right? So that means if it's moving toward the coin, well, number one, which distance are we talking about? Which distance is changing? It's x, isn't it? So I've got dx on dt, because with respect to time, okay? Now, is it getting bigger or smaller? It's getting smaller because it's getting closer, right? So that's why you've got this being -4, okay? Now, because what you're after is dA on dt, right? Of course, the way that you get this is, well, you've got your a as a function of x here, up there, right? So you can differentiate that with respect to x after you expand everything out, and what you want to multiply that by is dx on dt, which is what you've got here. Okay, so your algebra takes a little while here, but you do get there. You get it to be equal to, let's see, here's what you get. 2 pi squared d squared times -4. And of course, when you put your value of d in there, then it all simplifies out when x equals d. You get down to this rate. A whole bunch of the d's cancel. Oops. So there you go. That's what we were looking for. There was the second mark. Okay? So, one up here for doing the proper differentiation, and then the other one for the simplification that happens after this. Okay?